Alright guys, welcome to lesson 4.4, factoring polynomials. I know one of your favorite things, factoring. So we are going to look at some more ways that we can factor, but before we get started, our objective for this lesson is to factor polynomials over the real or complex number system. So remember that complex number system is where our imaginary numbers come in. And then our success criteria is, by the end of this, you should be able to say, I can use special factoring patterns, I can find common monomial factors of polynomials, I can factor polynomials. Alright, so starting off, this key idea is going to be very helpful. It gives us different ways that you can factor based on patterns, and I do have these up in the classroom as well. But this is something you're going to need to reference as you're doing your practice. Alright, so let's just dive into example 1 and see how these are helpful. So if we look at this first one here, we have x cubed minus 125. Well, that cube tells me it's a cube, and I have a minus sign. So if I look up here, I'm looking at difference of two cubes because I have a difference and I have a cube. So I need to rewrite these in this format so that I can easily turn them into that pattern. So how can you do that, you ask? Great question. We're basically going to find what is the cube root of this, what is the cube root of that, and that will give us our a and our b value. So what is the cube root of x cubed? Well, that would be x, because remember I taught you that the cube roots and these cancel each other out. They're like, I can't think of the word, I just lost my word. I'm so sorry. Y'all know what I mean though. And then we have the cube root of 125. So what number can you multiply to itself 3 times to get 125? You can always use a calculator for help too. So what does that mean? That means our a value is x and our b value is 5. So we're going to take this pattern and we're going to rewrite this to fit into that pattern. So my pattern is a minus b times a squared plus ab plus b squared. And so now all I'm going to do is put in my x for my a and my 5 for my b's. So I have x minus 5 x squared plus a times b, so x times 5 would give me 5x, plus b squared, so 5 squared would give me 25. And I'm done. Right? It's that easy, but you have to know what your a and your b value is. That's the most challenging part. Alright, this next one, we look at it. I know 25 is a perfect square. I have a square there, and I know 4 is a perfect square. So I have an addition symbol, so I'm going to go up here, and I'm going to look, and I have a sum of 2 squares. Now notice, this is where our imaginary numbers come into play, because technically, this does not work with real numbers. And the only way we've seen it work before is with the difference. So that's why the imaginary numbers are there. Alright, so again, we need to know what is our a value and what is our b value. How do we find that out? Well, we're going to take our first term and we're going to find the square root of it. So what is the square root of 25w squared? So take one part at a time. Square root of 25 is 5. Square root of w squared, remember that cancels each other out, so it's just w. And then we have square root of 4, which equals 2. So we said this was a sum of 2 squares, so the pattern that we're going to use is a plus bi times a minus bi. Because if you remember from the lesson on imaginary numbers, when you multiply them and you get I squared, it gets -1, so they kind of cancel each other out. If you're to work them back out, you will get this as your answer. You're welcome to try it if you would like to see. Alright, so we have 5w and we have a 2, so we're going to say 2i. Then we have 5w and minus 2i. Alright, so like I said, based on what we learned about the values of i's, if we were to work this out, do say the box method, you would get back to this. There would be no more i's. Alright, last one we're going to practice. This is a cube. I can find the cube root of 8. I can find the cube root of 27. There's a plus sign in the middle. So that means we're doing the sum of 2 cubes. So again, I need to know what is my a value, what is my b value. How do I find that out? I'm going to take the cube root. So cube root of 8t cubed. So cube root of 8, 2 times 2 times 2 gives me 8. So I know that's a 2. And t cubed, the cube root of that is just t. Then I need to know what number times itself 3 times equals 27, or put it in a calculator and you would get 3. So now we're going to put it into our pattern. All right, we have 2t, or actually I'm going to write the pattern down. I don't know why I didn't do it. I guess because it's like right there, but yeah, I'm going to write it down just so we have it for fun. A plus b, a squared minus ab plus b squared. All right, so a is 2t, b is 3. Now this is where we got to do a little extra work. So in this case, a is 2t, but we're squaring the whole thing, not just the t. So be careful. All right, be careful with this because this could easily change your answer if you don't remember this rule. All right, then minus a times b, so 2t times 3, and then plus b squared, so plus 3 squared. So let's just simplify this. So now we have 2t plus 3. So remember, you have to distribute this 2 to each term inside. So this becomes 2 squared t squared, which would be 2 squared is 4, and then t squared. And then 2t times 3 would give you 6t, and then 3 squared would give you 9. And that would be your answer for that one. Okay, so here's our self-assessment questions. I would like for you to try all 3. I know some of you won't. I would like for you to at least try that one and one other one at the very minimum. Try 2 of them, but make 3 because we didn't actually do one like 3, so that way you have an example. I would say this one in either 2 or 4 if you're only going to do half of them. But here's the thing about factoring. You get better by practicing, by doing the different types. You'll start to see the patterns easier. So your best bet is to try all 4. But if all else fails, try at least 3 and either 2 or 4. All right, so please pause the video now and then come back and we'll look over them. Okay, if you didn't pause the video yet, please pause it. All right, so I went ahead and worked them all out, but I did show how I found the A, B, and the A and B value, and then I did write down which one I used. So if you have a question about one of these, like maybe you did it differently and you don't understand what you did wrong, put a star by it in your journal. Ask about it when you come to class. All right, so now we're going to look at a few different other ones. All right, and we're going to look at factoring completely. It will involve some of these, so this doesn't completely go away. So some polynomials with degree greater than 2 can be factored completely using techniques you have previously learned. A factorable polynomial with integer coefficients is factored completely when it is written as a product of unfactorable polynomial with integer coefficients. So you're like, Ms. Gill, how do I know when it's unfactorable? When you can't factor it no more. All right, that's as simple as I can put it. All right, so looking at page 2, example 2. The first question, you ask yourself, do the terms have something in common? And then go from there. So do they all have the same variable? Do they all have the same coefficient, like a factor of it? All right, so for example, looking at A, I notice every single one of them has an x in common. Their coefficients aren't in common, but they do have an x. So I'm going to start there. Start by factoring out an x. So you can think about factoring out an x as dividing. If you remember your rule, exponent rules from dividing, you just subtract your exponent. So there's technically 1 there. Or you could think about it, x times what would give me x cubed. So I know that's x squared. which is the same as saying 3 minus 1 gives you 2. So a couple ways to think about it. All right, then we have minus 4. X times x gives me x squared. And then I took that x away, so I've got 5. All right, another way you can think about it is there's one less x in each one of them. All right, so are we factored completely? No, because I have a square here and I can still factor here. So here's where we're going to go to the way that we factored in chapter 3. We're going to look for two numbers that when you multiply them, you get negative 5. When you add them, you get negative 4. So if you said 5 and 1, because that's really our only options, you are correct. But because our adding term is negative, that means our bigger number is negative. So now, for this part, we're going to turn it into the two binomials like we have previously. We're going to just bring down this x. And so we have x minus 5, x plus 1. Now, it is unfactorable. There is nothing else that we can factor. They're all exponents of 1. All right. All right, let's look at the next one, b. So, looking at it, they have z's in common. The smallest z is c squared. And then can everything be divided by the smallest number? So can we divide all of those by 5? We sure can. So we can actually factor out a 5 and a z squared. And so we're going to do it just like we previously did. You could think about it as dividing. You could think about it as I took 2 z's away, there's 2 left. Whatever makes it easier. 5z squared times what would give you 5z to the 4th. There's multiple ways that you can do to help you with this. You have to find the one that works best for you. All right, you can think about it. 5 times what gives you 30. We know that's 6. And then I took 2 z's away, so 1 z's left. That's a way to think about it too. 5 times what gives me 45? 9. So, can I continue to factor? Yes, because I have a square there. So again, I'm going to think, what are two numbers that I can multiply to get 9, but when I add them, I get 6. If you said 3 and 3, you are correct. So this would become, we would write our 5z squared down. This would become z plus 3, z plus 3. Since these are the same, we're not going to leave them written like that. We're going to rewrite them as z plus 3 squared. All right, so that's how our final answer would be written. All right, for some polynomials, you can factor by grouping. So we've actually practiced this a little bit in chapter 3, and you did do this in algebra 1. So we're going to kind of revisit it. Right here is the pattern, though. Remember, what's inside these parentheses has to be the same. So, for example, I'm looking at this one. I am going to factor by grouping. So I'm going to group the first two together. I'm going to group the second two together. So I'm looking at what does just the first two have in common. Well, this one doesn't have a coefficient. They both have z's, the smallest one being 2. So I can factor out a z squared. So if I factor that out, what goes inside here? So z squared times what would give me z cubed? Just z. Z squared times what would give me 5z squared? Just 5. So then with this one, I have to have z plus 5 in the parentheses. So I need to know what can I factor out to make this true. Well, I definitely have to factor out that negative sign. And then what about this 4 and this 20? Well, I know that 4 times 5 is 20. So I can factor out the 4. So these two, the signs have to be the same. They have to be exactly the same. All right, so now we're going to take our term on the outside and make them 1. So this becomes z squared minus 4. And then we have z plus 5. All right, so we are factoring completely. So notice here, z squared minus 4. We can go back to that first lesson, and we have a difference of squares. So we need to factor that out. So remember, our difference of squares was a squared minus b squared equals a plus b times a minus b. So that's what we're going to do with this one. So if you need to make a little note, how did Miss Gill go from that to that? This is how. All right, so we're going to rewrite this one then as z plus 2, because remember, in this case, our a value would be z, our b value would be 2, because the square root of z squared is z, square root of 4 is 2. And then we're going to have z minus 2, and then z plus 5. So this would be no longer, you could not factor anymore. This would be as much as you could factor it using grouping. All right, so remember, you always got to ask yourself too, am I done? Can I factor some more? All right, one more type to look at. When they're in quadratic form. All right, so first question we ask ourselves is, do they have something in common? You're going to ask yourself that every time. Well, I know they have an x in common. Does the number 36 and 81 have a same factor in common? If you said 9, you are correct. So we're going to factor out a 9x. So when we factor that out, what is left? So 9x times what? Gives us 36x to the 5th. So 4x to the 4th. Then 9x times what? Gives us negative 81x. Negative 9. All right, but there's a pattern here. I know, because that 4 means that we can go further. So the pattern that we're going to use is the a squared minus b squared pattern again. So that is our a plus b times a minus b. So that's what we're going to do for this one. All right, so just for this part, we're going to use that pattern. All right, so we have our 9x. We need to know what's our a value, what's our b value. So let's write that over here. So our a is 4x to the 4th. So if we take the square root of that, we get 2x squared. And our b value is 9. So if we take the square root of 9, we get 3. All right, so, and guys, if you need practice on this, again, come see me in my group. We can practice doing these. It's fine. That's what I'm here for. All right, so we have 2x squared plus 3, 2x squared minus 3. And even though this is a squared, we really can't do anything else with it. With the 3 isn't a perfect square. So that is actually as far as we can go with that one. All right, last one. Factor completely. So first thing we're going to look at, do they have something in common? Well, they all have p's. Smallest one is p squared. Can they all be divided by 3? Yes. So we're going to factor out a 3p squared. All right, once we factor that out, what is left inside? So we have p to the 6th, 5p cubed, plus 6. All right, so this one is a little different but similar. All right, looking at this, I know I can factor this part further. But there's a reason why it says quadratic form. So I know that I can have p squared plus p squared plus p squared equals p to the 6th. So we could actually think about this as two numbers that you multiply to get 6, but when you add them, you get the 5. All right, stick with me here. So two numbers you multiply to get 6, add to get 5. 3 and 2, because 3 times 2 is 6, 3 plus 2 is 5. So before we have p squared, we would separate this and say p times p. Well, now we can separate this and say p cubed times p cubed. And then we're going to have a plus 3 and a plus 2, like we would have before if it was just squared. Now, can we factor any further? Is this a perfect cube or is that a perfect cube? They are not. So this is as far as we can go. All right, so the only way to really, in my opinion, to learn these is to try them. All right, is to try them. So I have quite a few here. I would like for you to try them all. At the very minimum, I would like for you to try maybe like all 4 of these or all 4 of those. That way you're getting a little bit of something different. But I would like for you to try them all. So please do that. And pause your video and give it a try. This is all you got left. And that's the way you can practice to know if you need to ask Ms. Gill questions or if you're ready for the big ideas assignment. All right, so here's number 6. Started off factoring out the x, left us with this. Thought about two numbers multiplied to give me positive 10, the add to give me negative 7. And so that's how I got that part. So now I'm going to do number 7 if you haven't tried that one already. Left us with two numbers multiplied to get positive 1, add to get negative 2. So these were repeated, so I was able to rewrite it as a square. So your final answer should look like that. All right, if you haven't tried 9, please try it now. Again, the more you practice these, the better you will get. All right, so for this one, I had to use, once we factored out this 6z squared, we did the difference of 2 cubes. So that's what this part is, the difference of 2 cubes. All right, so if you haven't tried 10 or 11, try 10 now, please. So I wanted to come back on this one. So this was factored by grouping. So we have this x squared minus 1, x plus 4. But remember, 1 is a perfect square because 1 times 1 is itself. So you do have to do the difference of 2 squares on this one. So it would actually be x plus 1, x minus 1, x plus 4. So maybe you stopped at this part, but remember that that 1 is a perfect square. All right, if you haven't tried 11, please do so now. Now we're with this one. 3 is not a perfect square, so we cannot factor that any further. That is factored as far as it can. All right, if you haven't tried 12, please try 12 now. All right, and so here's number 12. All right, this one was a difference of squares. We can't go any further because 5 is not a perfect square. So last one is 13, and if you've hung around this long, there's an extra credit question to come after this number 13. All right, last one, number 13. So after you factored out the 5w squared, you had to think about two numbers that multiply to get you that one and add to get you the other. Okay, so if you stuck around this long, you deserve some extra credit. So if you want to give this question a try, email it or turn it in and you'll get some extra credit points. Write an expression with two variables that can be factored using the difference of 2 squares pattern, then factor the expression. So you're just basically making up your own question and then working your question out. All right, so turn that in. If you made it this long, I will even give you some extra points for watching the whole video. All right, have a great day. I will see you in class.